Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad, India. In this session, we are going to study some more problems in the concept of calculating the resultant force of a system. Here, in previous session, we have covered some of the problems related to here. In the same model, we are going to how the direction with different direction of forces acts, and how to calculate when the various forces acts in different direction, how to resolve those force components and calculate the resultant force. Now let us recapitulate some of the fundamentals of system of forces. There are various system of forces, such as number 1, coplanar force system, and number 2 is non-coplanar force system or spatial force system. In the case of coplanar forces, it is categorized into different types. It is categorized into different types. The type 1 is collinear forces, and the second one is concurrent forces, and the third one is parallel forces. Now we have to find out, in this course, engineering mechanics course, we'll focus mostly on coplanar force system. It can be what type of force system, we have to identify it. If it is the coplanar concurrent force system, in the case of coplanar concurrent forces, all the forces acts on a particle and meeting at one point. This type of force system is known as concurrent forces. These forces are acting in the same plane. That's why it is known as a coplanar. It's a coplanar force system. And this is a coplanar, and meeting at one point is known as concurrent, coplanar concurrent forces. And what is the meaning of collinear? The collinear force system, coplanar collinear forces. In the case of coplanar collinear forces, the forces which acts along the line of action, it can be the same direction or in opposite direction, but the main thing is that collinear, same line. Okay, and the third category is known as the coplanar parallel forces system. Coplanar parallel forces. In this coplanar parallel forces, all the forces doesn't meet at one point, but having parallel to each other. If all the forces are acting downwards parallel to each other, then these forces are acting on your body. These forces are like parallel forces. What about another? Suppose some of the forces are acting upwards. The direction of some of the forces are downwards and two forces are upwards, but all parallel to each other. That's why this type of force system is known as coplanar, unlike parallel forces system. Now, coming to the picture of this coplanar forces, Here it is the figure 1 mentioning what type of force system here it is. Definitely all the forces are acting in the same plane. No doubt about that. It is the coplanar forces. But is this acting at any point? All the forces are acting meeting at one point. Suppose the AB 40 kilonewtons, 40 newtons acting at point A, and this BC is acting 50 newtons acting at point B. And what about AC is acting at point C? These forces are not acting at single point. These are the forces which are acting at different points, point A, point B, point C. Based on the concepts which we understood, which we discussed now, the system of forces, then this figure 1 comes to what type of system of force system here, what type of comes under the category, what type of system of force. Yes, first broadwise, it comes under the category of coplanar force system. It's not a non-coplanar, but it's in the same plane. Then you may ask me what type of non-coplanar. Real field, yes, if you're keeping two hands like that, it is in x direction, you may keep it. One is x direction, one is y, and then one is z. It may be acting. It may seem both are in the same plane in front of you, but it is not on the same. One is here, another direction, another one. So these are the forces acting at one point. These are the special force system or non-coplanar forces. So the camera stand with which the stand on which the camera stand keeps, the stand is having x, y, z directions. This is a non-coplanar system. Then the building which is constructed, that's the non-coplanar. It's not a coplanar, same planes. So how can we simply understand, is this coplanar or non-coplanar? Yes, it's the two-dimensional things. We are studying on two-dimensional scale system, then it is known as coplanar. If it is in three-dimensional, then it comes under the category of non-coplanar. So by using those concepts, now here we are solving the problems. What type of problems we are going to solve? Here we are studying the coplanar force system related problems. Now this figure 1 indicates what type of force system here it is. It comes to the category of type of force system. What type of force system? The type of force system here, yes, anybody can answer. It is not concurrent. It is not at all parallel. And is this collinear? No. It is a coplanar non-concurrent force system. It comes under non-concurrent. So you may call it non-concurrent system means coplanar non-concurrent. Non-concurrent means it is not meeting at one point. Then you can also call it as parallel force. No. The parallel force system also known as the coplanar non-concurrent force system. Now here is the coplanar non-concurrent forces and non-parallel forces, non-concurrent non-parallel force system. This is the combination of non-concurrent non-parallel force system, and it is not at all collinear also. So the system of force here it is mentioned coplanar, non-concurrent, non-parallel. One more thing, non-collinear force system. So this type of force system is not at all mentioned in the system of forces. The type of system of forces descriptions we have learned. But those concepts are useful to apply in the real field problems and understand what are the system of forces in the real field applications and also in solving the problems. Now, for such case, how to find out the resultant force? At that time, we have to use the resolution of a force system. The concept of a resolution of force come into the picture. So, in the concept of resolution of the forces, what we are going to do? We are going to resolve when the force, any force component is having certain direction. The direction and magnitude, the direction can be either acute or obtuse angles. Then we have to resolve that force component into horizontal and vertical. Then what to do after that resolving? We have to go for algebraic sum of all horizontal component value, and you have to make it another vertical component, algebraic sum of vertical forces sub value. Then the resultant force equal to the square root of horizontal component forces value whole square plus vertical force components forces value whole square, the value of that. That is the resultant, that the magnitude of the resultant force. Okay, with that concepts, yes, let us just a glimpse. We have to solve very quick revision. We are going to solve this. Yes, here the 50 kilo, there are 50 newtons, 40 newtons and 30 newtons. The 40 newtons is a horizontal zero angle, and 50 newtons the force component. 50 newtons force component is vertical. So both are 0 and 90 degree, no need to resolve. But the 30 newtons force which is acting with some angle. Okay, that angle is, what is that angle? Here it is. We have to find out with inclination. That inclination can be found out. We know the adjacent side and we know the opposite side. What about diagonal side? The diagonal side AC equal to under square root of 40 square plus 30 square. Then it becomes 50. Now AC equal to 50 millimeter. From this, whatever cos theta equal to 40 by 50, that becomes 0.8. Sin theta equal to opposite side by diagonal 30 by 50, that is 0.6. Now resolve this 30 newtons horizontal and vertical. If you make it horizontal, 30 cos theta. If you make it vertical, it becomes downwards, that is 30 sin theta. Now how can we make a transfer all this here at this point? The effect of these forces is same. If you maybe the distance may be 30 meters, by using which law of force? By using the concept of law of transmissibility of force system. It may be acting here 30, it may be 50. The 50 kilonewtons can be placed here also 50 upwards by using law of transmissibility of force. Now all these forces we have to make it transfer to one component. Yes. So we are considering here horizontal and vertical forces. From this, sigma h equal to positive 40 minus 30 negative 30 cos theta. That is 40 minus 30 cos theta, that is 0.8. 40 minus 24. 30 cos theta. 40 minus 24 is 16. Then what about sigma v? Sigma v equal to, what is sigma v? 50 positive minus 30 sin theta. What about sin theta value? 0.6. That is 50 minus 18. That is 32. Whatever resultant R equal to under square root of sigma h square, that is 16 square plus 32 square. The value will be obtained resultant. That is what magnitude of these forces. Now with these concepts we already solved problems in previous session. And let us give a glance on the second model. Here there is all the forces are acting either horizontal or vertical in this figure 2.4. But there is no component of force having with some inclination, neither acute angle or obtuse angle, So no need to go for resolution. Already the force components are either in horizontal or vertical. Now directly we can crack it. That is the sigma h equal to, what are the horizontal components? Is the positive x and the negative x. That is 25 minus 20, that is 5 kilonewtons, sigma h. Whatever sigma v, 50 kilonewtons, negative y. 50 kilonewtons downwards, negative y. 35 kilonewtons, negative y. The vertical downward direction, negative 50 and the negative 35, that is negative 85. Whatever resultant are equal to sigma h square plus sigma v square. What is sigma h? 5 square v square. Thus, the resultant force is obtained. How much? The value of the resultant force is 85.15 kilonewtons. So, what is the magnitude? It is asked here. Yeah, determine the magnitude and direction of the resultant force. This is the magnitude of the resultant force. The magnitude of the resultant force is 85.15 kilonewtons. The magnitude of the resultant force is 85.15 kilonewtons. And whatever direction, the direction of the resultant force, tan theta equal to, as I told you, tan inverse of 85, that is sigma v by sigma h. The sigma v by sigma h, that is 85 by 5, that is 17. Theta equal to 86.6. But with what result? How can we know what is theta? Is the positive towards positive x direction? Resultant force is there. It comes the positive x, positive y, negative y. So what the value of sigma v is negative, that is 85 downwards, and sigma h is positive, that is 5. So the resultant force theta, it is how much? 86.6. That is the angle, this is with which it is acting, theta. That r equal to, the value of the r is 85.15. R equal to 85.15 kilonewtons. Now, what is the angle? This is the 86.6 with the x-axis, positive to direction. If you want to find out this angle, that is 360 minus 86.6. 360 minus with which the resultant force is acting with the horizontal axis. This is the theta actually. That is 273.4 degrees. So here the sigma h is positive and sigma v is negative. That means the resultant force will be in between 270 degrees and 360 degrees. Okay, 360 degrees is again positive x and 270, that is the fourth quadrant. In the fourth quadrant it will be, the resultant force will be. Okay, here with that the resultant force, the magnitude of the resultant force is 85.15 kilonewtons, and the resultant, the magnitude of the resultant force is 85.15 kilonewtons, and the direction of the resultant force is either 86.6 from 360 degrees downwards, or it is the 273.4. So the actual angle of the resultant force is between 270 and 360. That means you have to come out from 0 degrees to, that is 360 minus 86.6, that is 273.4 degrees. That is the value of the resultant force. Okay, now next we are going to solve the next problem. The forces 20 newtons, 30 newtons, 40, 50 and 60 newtons are acting at one of the angular points of a regular hexagon towards the other 5 angular points taken in order. Find the magnitude and the direction of the resultant force. What is R value? and what is the theta value? What is the r value and what is theta value, the direction? So if you make it based on the hexagon, this hexagon, based on the hexagon, the 5 angular points, okay, 5 I'm taken in order. The order is that first 20 newtons horizontal, it looks here 30 degree. If you measure this angle, because the angle, what is the angle? 120 degrees. This is the 120 degrees per hexagon. That was 360 by 6. So it becomes, what is the angle? Total angle. The angle, if you measure, here it comes. If you want hexagon, how many points are there? 1, 2, 3. Actually, if you make it now 120 degree, that here 120 degree by how many point divided by, that is equal division, that is 30. So that's 30 degrees it is making. Now here it is 20 and next 30 newtons, 40, 50 and 60 newtons. How to find out the resultant force? Now the resultant force sigma h, the resultant force are equal to under square root of sigma h whole square plus sigma v whole square. What is sigma h? The concept of sigma h is that algebraic sum of all horizontal forces are equal to sigma h square plus sigma v. Sigma h equal to algebraic sum of all horizontal forces. Here there is another term, horizontal forces will come. That sigma v equal to algebraic sum of all vertical forces. So those terms, how to make it resolution? Now the concept is that sigma h, we are going to make it. So we are going to follow the method. There are various methods are there. One of the method here is the 20 newtons horizontal and 50 newtons vertically, 90 degrees. Okay, cos 90, 50 times cos 90 is 0, 50 times sin 90 is sin 90 equal to 1. That's the vertical. The next term is that, yes, we are going to resolve it. We'll apply one of the method so that you can understand. The 30 cos term. This is the 30 cos, the angle is 30 degrees. 30 cos 30. And vertical component, draw a parallel lines and vertical lines, 30 sin 30. The next, you can take another force, make it parallel, vertical extension. The angle with horizontal axis, how much? It becomes 60 degree. So it is 60. Then horizontal was 40 cos 60 and 40 sin 60. The next force, what is there here? Draw horizontal vertical lines, parallel to x and parallel to y. Whatever the angle with which it is making 30 degrees, this become horizontal component. The horizontal component for 60 is, this is 60 cos 30 and it becomes 60 sin 30. For this resolution, the horizontal base here, for whole system, the 60 cos 30 is the vertical for complete, if you complete global level. Now, we resolve the horizontal and vertical when the force components are making some inclination with some angles. What is sigma h? Sigma h equal to, make it all algebraic sum of horizontal component of forces. Alright. Sum of the component here 30 cos 30 is positive x, and 30 sine 30 is also positive x, and negative 60 sine 30 is the negative x. That value, the sigma h that equal to, it becomes 36 newtons. What about sigma v? Sigma v value, follow this method, it will be, otherwise you will get confusion. Now what are the vertical components? 30 sine 30 is the positive, plus 40 sine 60 is upwards to positive y, plus 60 cos 30 is the positive y. That value will be, what is that value becomes? 151.6 newtons. This is the method. If you follow the way we resolved it, horizontal and vertical, and finally sigma h and sigma v, these values come same as now. Now after knowing the sigma h and sigma v, what is the resultant force? The resultant force R equal to sigma h whole square plus sigma v whole square, and the direction equal to tan inverse of sigma v by sigma h. Now let us go for the next method. You see how it becomes. In this sigma h, you observe it. Algebraic sum both positive and negative, and also cos and sine and cosine terms are there, both in sigma h and sigma v. And another method is also you can follow. We are considering all the forces are making with a positive x. That's what here we applied concept. All positive x means all terms convert into cosine terms, cos terms. 60 cos how much? 30 plus 30 plus 30. 60 cos 120. 120. 40, 50. So 50 is the term directly. 50 cos 90, it becomes 0. 40 cos 60. 30 cos 30 plus 20. That's what we followed here. Sigma h equal to 20 cos 0, 0 degree. 30 cos plus 30 cos 30 plus 40 cos 60 plus 50 cos 90 and 60 cos 120. Then that sum is cos 0 equal to 1, cos 90 equal to 0. That's why this become 50 becomes, in horizontal component becomes 0. That is sigma h. And whatever sigma v, make it all positive vertical axis, all positive vertical terms. What are the vertical terms are now? Sine terms. This is 20 sine 0 degree plus 30 sine 30. Yes, sigma v equal to 20 sine 0 plus what about 30? 30 sine 30. Next 40. 40 sine 60 plus 50 sine 90 plus 60 sine 120. This is what we followed here. 20 sine 0 plus 30 sine 30 plus 40 sine 60. That means here in this method, method 2, we made it all are making the positive x resolution horizontal components, positive direction. Here for my side, if you see, it is positive here direction, and positive vertical, positive y and positive x. That's why sine and cosine. What about r equal to under square root of sigma h and sigma v? The value of the sigma h value is 36 newtons. Sigma v value is 151.6 newtons. The resolution of force R equal to, this is the positive first quadrant. The R equal to sigma h square, that value is obtained 155.8 newtons. What about theta? Theta equal to tan inverse of 151.6 by 36. That is 4.211. Values tan theta. Theta equal to 76.6 degrees. What is the value of theta? 76.6 degrees. So here in this problem, we considered two methods we solved. One is we resolved as it is both vertical and horizontal components. And in the method, second method, we consider all force components are acting with respect to AB. the positive x direction, all cosine terms, and the vertical components comes in all sine terms, vertical components. That resultant is become 150, got value as 155.8 newtons. So beautiful engineering, here it is. 20 newtons, 30 newtons, 40, 50, 60. There are various forces are acting on a particle A with different angles, with different directions. All these forces affect that culmination, sum of all the forces affect is the values here 155.8 newtons. And the magnitude with which the effect of the force, that is, here it is, that is 76.6 newtons. So all the forces are tensile, acting away, this point A. Then single force, that single force is the force, that effect of all these forces equal to the single force, that is 155.8 newtons. That is the resultant force. All right, we followed some of the references. Here, the reference 4, reference 1, 2, 3, these are the standard books. And some of the problem solving books also there, concepts which you can follow to gain the concepts of engineering mechanics. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.